Okay, today we are talking about section 9.8. This is going to be part one of two. And this is data and statistics. This is algebraic, mostly. There's also a graph that we'll introduce. Couple of things. When you do data, you generally take a sample. Now, you could take a census, which means you attempt, and you fairly strongly attempt to contact everybody in the population. The US takes a census every 10 years, and they try to get everybody from the population. They don't succeed, even with all the money the government has. And with the fact that it's illegal to not fill out your census form, they still don't get everybody. And it's honestly not even that close. They don't even get all people that are legally in America counted in a census. So you definitely don't get people that are here illegally. You're not going to report yourself to the census. But even if you're here legally or a citizen, there's a lot of citizens that don't fill out their thing and get counted. So a census is very, very hard to do, a proper one. If you just get the people that want to reply, that tends to produce different results than a true sample of everybody. So oftentimes we'll use samples and infer things based on a certain amount of error. And that's called inferential statistics. So a parameter, which is what I'm trying to draw conclusions about, is a data point about the actual population. That means everybody, not just those that participated in the census, but actually everybody. A statistic is what I'm estimating my parameter with, which is what I can calculate from my sample. Okay. So if I take a sample of 1,000 high school students to draw conclusions about their social media habits, I will randomly select 1,000 high school students. Ish, I might select a few more because I might not be able to get a hold of a few, but I will try very hard. But I will randomly select high school students and check on their questions. And then I will use that to draw conclusions about the population, because contacting every high school student and getting them all to reply would be really, really expensive and difficult. So we're going to distinguish a parameter from a statistic. This is example one. In a 1996 study called Kids These Days, What Americans Really Think About the Next Generation, reported that 33% of adolescents say there is no adult at home when they return from school. The report was based on a survey of 600 randomly selected people aged 12 through 17 years old and had a margin of error of 0.4%. So they're saying that it's somewhere between, they believe the true percentage is somewhere between, so if it's 33% was what they got, they believe the true percentage is between 29 and 37, plus or minus 4%. Did the survey measure a parameter or a statistic? It measured a statistic. It was a average of the sample. It was meant to draw conclusions about the parameter. The margin of error simply means plus or minus 4% means we believe the true parameter is somewhere between 29% and 37%. And in this case, it was between 29 and 37% of students ages 12 through 17 return home to a house that's empty. It doesn't have a parent at home. Okay. That's parameter versus statistic. I believe you know how to calculate mean, median, and mode. Let's hope at this point. If you don't, pay attention quickly here. Mean, this might be new. This notation, we call it X bar. It's X with a line over it, is the mean. Here's some notation. Oh, no. A little bit of maybe new way of notating it. But you know that the mean is you add up all the numbers and divide by the total number of numbers. Oops. Here's another way of notating it with some of our new notation. The sum from I equals 1 to n of x sub I, which means each value, the first value, the second value, the third value, and then times by 1 over n, which is the same as dividing by n, or the total number of numbers. Okay, you may look at example 2 if you don't remember that. We have the median. The median is the middle number. Important thing, order the set. Before you start finding the median, order the set from smallest to largest. If I've got 5 data points in the set, this is the median, we call it capital M. If I have an even number of data points, so odd number, you just go to the middle. A lot of times when I'm doing it, I just go like this. Start crossing my way off. Oh, I found the middle one. This, I have an even number. I'm doing small data sets here. Ooh, I got these two. So what do? I take the mean of them. 4 plus 7 divided by 2. The median is 5.5. We'll get back to this when we talk about 5-number summaries. The mode is most frequently occurring number. There can be multiple modes. There can be no mode. If nothing occurs more than once, there is no mode. If there are multiple that occur the same number of times, it's the most. So say I've got a number that occurs 4 times in my set, and I've got 3 numbers that occur 4 times. I've got 3 modes. It is often helpful to put your set in order for this. If you look at example 4 in the book, 44 occurs 4 times. That's the mode. 39 is twice. I don't see anything else being more than 34 is twice. If you have 2 modes, it's called bimodal. You could have 3 modes. Usually you only have 1 or 2. Usually. So mean, median, mode. Hopefully you learned that years ago. And this quick little refresher reminds you of everything you need to know for those. Okay, couple of things to know. The mean and median are both measures of what we call, actually all of these are measures of center. Oops. We're going to talk about measures of spread later. The mean is considered non-resistant. Let's pretend I add a number to this data set. 1,000. That is going to drastically raise the mean. The mean was 15, 18, 22 divided by 5, 4.5. Now I've got 1,022 divided by 6. 170. That drastically changes the mean. So that number of this 1,000 would be what we call an outlier, because it doesn't really fit the rest of the data. But it definitely is there. The median now just goes here, the middle of those two, 5.5. So the median is called resistant. Often it'll even have less effect on the median. The mean, adding this 1,000 made it go from average of 4.5 to 170, but the median only changed a little bit. Mode, usually adding one outlier does not drastically affect the mode. Okay? So using a frequency table, I'm going to go through and write out this frequency table here. This is going to be example 5. This is a 10-point quiz. Let's hope none of these students at the bottom end are you. Let's hope you guys are all at the top end. Quizzes. Oops, I forgot the 0. 2, 2, 3, 8, 4, 3, 3, 2, 1, 1, 1. So this is a 10-point quiz. What this tells me, I had 2 kids get a 10, 2 get a 9, 3 get an 8, 8 get a 7, 4 get a 6, 3 get a 5, 3 get a 4, 2 get a 3, 1 get a 2, 1 get a 1, and 1 get a 0 out of 10. My total in the frequency column adds to 30. So if I want to get my mean, I need to do 10 times 2 plus 9 times 2 plus 8 times 3 plus 7 times 8 plus 6 times 4 plus 5 times 3. I guess I'm most of the way. Hopefully you get the point by now. I'm multiplying the score by the frequency. And I'm dividing not by the 11 digits that I have, or 11 different scores, but by the 30 total students I had. So it's very important that you divide by the total number. And my average score is a 5.93. Guess the 3 is repeating. So yes, the average score on this quiz was an F. Or in the case of this school, a 1. That's kind of bad. We need to get that fixed, probably. That's using a frequency table and do something similar in example 6, using what we call a weighted mean or a weighted average. A weighted average takes into account frequency. So Marty's school and administrative policy is that the final exam must count 25% of the semester grade. Marty has an 88.5 average going into the final. What is the minimum score needed to earn a 90? So right now, he's got 88.5, and that's counting for, kind of looking at this table, 75% of his grade. 25% is this unknown final exam. He's trying to get to 90%. Well, what do? A weighted average, instead of dividing by the total, I just take the percentage or the likelihood. Actually, I should have wrote that in the other order. So here's the value. This is the probability or the percentage in this case. Ability. Maybe I can spell that. Same thing here. And this has to add up to 0.9 times 1. It's a whole grade. Oh, the book is nicer than I thought they would be. They said it doesn't have to actually add up to 90%. It just needs to round up to 90%. So that means 0.895. Now, when they showed in the book, they take this percentage and they divide it by 0.75 plus 0.25. We talked earlier in the chapter about probabilities. The probabilities always have to add. That's a very sloppy 5. So dividing by 1 doesn't do anything. So as long as they're legitimate probabilities, you don't need to divide. So if I solve this equation, I just 0.85 times 0.75, 0.885, sorry. Point 66375. So this gives me 0.66375 plus 0.25x equals 0.895. So I'll subtract this 0.66375 from both sides. Oh, sorry, it's not 88.5. That should be 0.885. I should convert my percent to a decimal because I did the other ones. Let me use a calculator on that. And I get here 0.23125. I'll divide by 0.25. And Marty is going to need a 0.925 or 92.5% on his test. Okay. I'm going to talk briefly about a 5-number summary and then box and whisker plots. The 5-number summary has the minimum, the quartile 1, the median, quartile 3, and the max. So if I take a data set, it's helpful to have it in order. I'm kind of writing with large spaces here, but that's just because I'm looking down. Okay, so, okay, this is fine. The minimum, 59. The maximum, 72.6. Those are pretty easy. The median, my two middle numbers are these two. I average them, which means I'm taking basically halfway between them. Okay, so 68.5, 68.75 is going to be my median. Quartile 1 and quartile 3 are just the medians of the upper and lower half. Now, if your median is not found, if you have an odd data size data set, you will brain, you will not include the median in your upper and lower half. if you have an even size data set, my median is actually not in this set. Even if the two middle numbers are the same, your median would be in between them. It's not in the set. So now I'm going to take the median of the upper and lower half. These ones I might actually have to add together. I can't just find the middle of that very easily. Okay. And that's 64.1. The upper set is all of this. The middle two numbers are here. That is 71.65. So this is my 5-number summary. Okay. And I'm about to make a box and whisker plot with this. A box and whisker plot has markings. The box goes from Q1 to Q3. And the whiskers, Q1 looks like about, this looks like about 64.1, 71.65. And then it has a line where the median is. The whiskers go out to the min and the max. This is me working on this one. Okay. I said measures of center are median, mean. There's a measure of center that goes with the mean that we'll talk about in part 2 called the standard deviation. But it's a couple measures of center here. You may have heard of range before. That's upper minus lower. It is not this. It is actually the value you get when you calculate that. 72.6, that's 13.6. And there's the interquartile range. This is the most commonly used one. The interquartile range, abbreviated IQR, is simply Q3 minus Q1. So 71.65 minus 64.1, and that equals 7.55. Okay? So that is a measure of spread interquartile range. That was a little bit of a twist on example 7, and that is the end of part 1.